Hello, Navarre's crew. We are back again with another lesson, and today we're going to be looking at comparing different fractions. So before we get into that, let's do a little bit of review from our previous lesson, which was lesson 17. We learned what a numerator and a denominator was. So let's take, for example, the fraction 1 over 4. The numerator is the number on top, and the denominator is the number on the bottom. A quick way that I remember that is just that I know that the denominator, it starts with a D. It reminds me of the word down. So it's like the down number, the number that's on the bottom. And then obviously the numerator is the one that is the opposite to that number on the top. And we also learned in our last lesson about equivalent fractions. And equivalent fractions are the fractions that have different numerators and denominators, but they are equal to the same value. And so an easy visual way to see that is if we look at all three of these different fractions, we have 2 over 3, 4 over 6, and 8 over 12. If we draw a line directly down all three of them, we can see that the shaded part of the boxes are all the same amount of shading. And then another way that we could show an equivalent fraction is to multiply both the numerator and the denominator by a different number. So if we look down here, we have 2 times 2 and 3 times 2. We're multiplying the numerator and denominator by the exact same number. So 2 times 2 would obviously be 4. 3 times 2 would obviously be 6. That means that 2 over 3 is the equivalent to 4 over 6. And same with 2 over 3 and 8 over 12, because we are just multiplying the numerator and the denominator by the same exact number. So now that we have some of that review out of the way, let's look at lesson 18, which is comparing fractions. So this first question here says Ayana and Lisa have tahini bars that are the same size. Ayana eats 2/4 of her tahini bar, but Lisa eats 2/5 of her tahini bar. Now the question is asking, who eats more of her tahini bar? So a simple way to figure out the answer to this question is to draw out some fraction bars. So I'm going to draw out 2 fraction bars. I'm going to try to make them roughly the same size, and that came out pretty good. So this first fraction bar is going to be Ayana's. And it says that Ayana eats 2/4 of her tahini bar. So that means that since the denominator is 4, there are going to be 4 pieces that complete this bar. So I'm going to break it up into 4 pieces. And then this bottom bar is going to be Lisa's. Lisa has 2 over 5 for her tahini bar, so that means there's going to be 5 pieces of her tahini bar. So let's break this up into 5 pieces. Now I'm going to take my highlighter, and let's highlight how many pieces that Ayana ate of hers. She ate 2 out of the 4, and then Lisa ate 2 out of the 5. So we can very easily see here that, well, it looks like Ayana ate more of her tahini bar. So for this first example, the answer would be Ayana ate more. And the reason that Ayana ate more is that there is more that is shaded in on these fraction bars. Yes, they both have the same the same numerator, but as we learned last time, if you have a larger denominator, that means that each of the individual pieces become smaller. All right, let's go to the next one. So this next question is around the same thing. It says Tomas and his twin sister Carolina have bottles of juice that are the same size. Tomas drinks 3/4 of his juice. Carolina drinks 3/6 of her juice. Who drinks more juice? So once again, we're going to break these bars up into the amount of pieces that are in the denominator. So Tomas would be 4 pieces. And then Carolina would be 6 pieces. 2, 3, 4, 5, 6. All right, so I'm going to once again shade in the amount that Tomas drank. He drank 3 out of the 4. And then I'm going to shade in the amount that Carolina drinks, 3 out of the 6. Once again, we can quickly see who drank more. It was obviously Tomas. All right, moving on to a little bit more complication here. This question says that a grasshopper weighs 2/100ths of an ounce. A beetle weighs 8/10ths of an ounce. Which one weighs more? So, because 2/100 is such a large number, doing a fraction bar would be kind of complicated for this scenario. Yes, we can do 8/10 on our fraction bar pretty easily, but the 100 is pretty steep of a number. So what we could do is we can mark out our 100 cubes and our 10 blocks. Now, I know this isn't the most effective way, but we're going to learn an even more effective way in just a moment. But let's just do this for right now. Let's look at the grasshopper. The grasshopper is going to be this first one. We're going to call him G Hopper. And then the beetle is going to be this one. So I'm going to take my highlighter again. For the grasshopper is only going to fill in 2 out of these 100 blocks. But the beetle is 8 out of 10 of them. So the beetle is quite a lot of these blocks. So we can very easily see that the beetle clearly weighs a whole lot more. But when we're looking at a problem like this, and we have 2/100 and we have 8/10, it's pretty simple in this scenario, but we can't always draw out the fractions as we see here. Yes, we could obviously do this for every single one, but that is just not time efficient. So a simpler way to do this is something called a common denominator. So let's look at this question again. So we have the 2/100 for the grasshopper, and we have the 8/10 for the beetle. Now, when I'm looking at both of these numbers, I'm looking at just the denominators. So I have 10 and I have 100. The first thing that I notice with these two numbers is that 10 is a multiple of 100. 10 can go into 100. So, how many times can 10 go into 100? I want you to pause the video and try to figure that out. All right, now unpause the video. If we look at this, 10 times 10 would equal 100, right? So what we want to do is we want to make an equivalent fraction to this one. We want to make an equivalent fraction with the same denominator. So here's what we're going to do. Since I know that 10 times 10 equals 100, I'm just going to multiply the numerator by the same amount. So 8 times 10 equals 80. And now I'm going to rewrite my fraction. So this would turn into 80/100. So now I can very easily see 2/100 compared to 80/100. We can very clearly see which one is bigger right here. And we were able to do that without having to draw out all of these different boxes. All right, so let's do one more example of using a common denominator to compare the two fractions. So let's look right here. It says Van's tomato plant is 8/12 of a foot tall. Her pepper plant is 3/4 of a foot tall. Compare the heights of the plants using less than, greater than, or equal to. So we have our first plant, which is going to be 8/12. And we have our second plant, which is going to be 3 over 4. Now, we can't really see right now which one is greater, or even if they might be equal. But what I can do is I can look at the denominators, and I can see that 4 can go into 12. Now, how many times do we need to multiply 4 to get into 12? Well, we need to multiply 4 times 3 to get 12. So whatever I do to the denominator, I need to do to the numerator. So if I multiplied 4 times 3, I'm also going to multiply 3 times 3. So now we have a new fraction of 9 over 12. So now if I write both of them out again, I can see that 9 over 12 is going to be bigger than 8 over 12. So now that we've had some practice with using a common denominator to compare the fractions, the next steps for you that you're going to do on your own are you're going to log on to iReady. I have assigned some practice activities. You're going to first play with the number line tool, and you're also going to play with the fraction models tool. And then if you're still a little bit confused, you're still a little bit lost, that's totally fine. I've also assigned the use common denominators to compare fractions quick lesson. And then if you feel confident and you're ready to move on, I do have a practice sheet that I've uploaded on Canvas for you to do. And then after that, we do have a lesson quiz to do. So good luck. You got this.